Hello,
Hello,
my name is
my
Santiago
name is
Francisco.
Christian Silvias.
Hello, my
The main problem of fossil fuels could be divided into two. The first one is that it's a non renewable source of energy, meaning that we will eventually run out of it. And the other one is the huge environmental impact that it has. And this is because it causes a lot of destruction when we are taking it from the environment and also when we are using it. The process when we refine it into whatever derivative, for example, gasoline, it takes it pollutes a lot and causes a lot of dangerous chemicals to be released. And also when we use these products such as gasoline, we release more greenhouse gases into the atmosphere, such as CO2. Due to all of the problems that fossil fuels bring, we have decided to implement and test new different ways from which we can get energy. And from this, a lot of clean and renewable energies came. And one of these is the solar cell, which is the most common up until now. And so, what it basically is that it converts sunlight directly into electricity, and it does that through the photovoltaic effect. So when the sunlight in the form of photons hits the cell, they transfer that energy to the electrons in the semiconductor, and that causes them to break free. And then this separation, in the end, it creates a flow of electricity. And so, a few advantages of the solar cells are that first, it is renewable energy. They are quiet in operation. They release no emissions when they are operating, and this helps us reduce our dependence on fossil fuels. And also, it comes with its disadvantages. And the main one is that initially it might represent a high cost or inversion, but at the end of the day, in the long run, it is going to be way better than just using conventional energy sources. But still, the initial cost is high. Also, is that it is weather dependent. So if it's really cloudy or your environment's just very rainy all the time, it might not be a good alternative. And also, the it has the issue of where to store that energy. So there are some batteries under development, but that is still something that we need to address. And as well the large amount of land that it would have to use if you want to generate large amounts of energy, and the manufacturing impact of actually making these. Okay, and now we move on to another source of energy generation, which is the one that we saw in class more in depth, and it is a galvanic cell. So it is basically electrochemical cells that they use a spontaneous redox reaction to generate electricity. Spontaneous meaning that it does not need an additional energy input in order to be happen. It just occurs naturally. And so they are composed of a cathode, which is where the reduction occurs, and an anode, which is where the oxidation occurs. And one gains electrons while the other one loses. And thus, the flow of electrons generates electricity. So, some advantages of this is that it is very portable, reliable, and it has a relatively simple design, as we can see over there. Though some disadvantages is that it is non-renewable, since we even saw it in the practice that the materials were degrading, so it is not renewable, and as well that causes for it to have a limited lifespan, and as well it has a kind of big environmental impact if not properly disposed of, because some of these galvanic cells use some heavy metals, and that could be dangerous for the environment if they're not disposed correctly.
Another clean source of energy production are fuel cells. Fuel cells work like batteries, except they can run infinitely as long as the fuel is supplied. Um, they consist of two electrodes and surrounding an electrolyte, and also make use of an electrochemical reaction, much like galvanic cells. However, the main difference is that galvanic cells have everything in the system, and fuel cells bring the fuel from outside. The most common fuel for fuel cells are is hydrogen, and it is very clean because the only byproducts from the reaction with hydrogen is electricity, heat, and water. Normal applications for fuel cells, especially hydrogen fuel cells, would be in hydrogen cars, which are powered instead of gasoline. They use hydrogen to power a fuel cell to generate electricity.
The objective of this project is to understand how electrochemistry concepts can be applied to create a battery system. This includes knowing how half cells work, a standard reduction potential, electrodes, and salt bridges. To build a galvanic cell, you need two things: a spontaneous reaction, which means that it does not need any more energy or external energy once it begins to continue happening, and a redox reaction to create the electric flow between the electrodes. So you have two electrodes, one is the anode and one is the cathode. The anode begins being negative, having a negative charge, but it loses electrons with an oxidation reaction. And the cathode starts as positive, but it gains electrons through a reduction reaction. Then you have those electrodes, which are metal plates, and you have them submerged in a solution that contains ions. It's an aqueous solution of whatever your metal is in with ions. The salt bridge is extremely important for this process because it maintains electric neutrality by allowing the ions to flow freely and complete the salt cycle. This is to avoid a buildup of charge and to maintain the ionic balance as well. And also you have a metal conductor which is connected to whatever you want to power on, like a tiny cell or maybe some other device.
For our results, our galvanic cell made using copper and magnesium was enough to power our toy clock enough for it to light up and beep. After testing the electrochemical cell, we found it generated a voltage of 2.72 volts, which was consistent with our theoretical voltage output potential between 2.5 and 3.5 volts.
Now we're going to present our discussion and some recommendations. First of all, the findings of this experiment emphasize learning and applying the basics of half-cell reactions and standard reduction potentials. It also became possible to strategically select appropriate electrode materials and electrolyte solutions to achieve the desired voltage range. Additionally, by understanding how different materials react and using the right setup, we can control the voltage. For the same reason, using a right salt bridge is important to keep the battery running smoothly by balancing ions. This shows the importance of every part of the battery setup for it to work well. Now on to some recommendations. The first one is to try alternative electrode materials that may offer higher voltages, lower cost, or better environmental profiles. Then, optimize electrolyte compositions and concentrations to enhance performance. The next one is to evaluate different salt bridges materials beyond sodium chloride. Then, measure long-term stability, durability, and performance under varying conditions. Also, quantify energy density and capacity in addition to voltage potential, and consider scalability and manufacturing aspects for commercial viability. In conclusion, as the need for sustainable and effective energy solution rises, the findings from this study hold potential to drive progress in battery technology and aid in tackling the present climate crisis. We found that the combination of a copper cathode and a magnesium anode, coupled with a sodium chloride salt bridge, proved to be an effective configuration for achieving the desired voltage to power a low voltage toy. Overall, this study successfully demonstrated the application of electrochemical concepts in the design and construction of a functional galvanic cell battery.